Now, next topic in the project management is project evaluation and review technique. Till now we have completed CPM. Now this is somewhat different from that of CPM. Okay. Now in this question, the difference from CPM is that in case of CPM, the duration for completion of activity has been given, but here not the specific duration has been given. Okay, the time has been given in the three forms. First one is the optimistic time, means the most minimum time in which the activity is supposed to be completed. Similarly, this is pessimistic time. This is the most worst timing, means the maximum time an activity can be completed in which, and this is the most likely time. Okay, and this is the time which is supposed to be most widely accepted. Okay, and finally for the using for completion of the network and analysis process, we have to calculate the total estimated time, and this time can be founded from these three times using this formula, that is TE is equal to T naught plus 4 times of Tm plus Tp upon 6. Using these three times we can find this value of Te. Similarly, for finding the probability and standard deviation, we have to solve for the variance of the question, and this can be found using the formula Tp minus T naught by 6 and whole square of that. Okay, so we will solve the question one by one. Initially, what is the requirement of the question? These are the 5 requirements of the question. Initially we will start with drawing the network diagram. Okay, as we are aware of drawing the network diagram, it is also a simple one, and you will see that for activity 1 to 2, 1 to 3, 1 to 4, these are the nodes. Okay, this is the starting node, this is the ending node for an activity. Okay, so you will see that for first 3 activities there is single node, means this is the starting point for 3 activities. This is 1. So one activity is 1 to 2, another activity is 1 to 3, and another activity is 1 to 4. Now after that you will see that there are 2 activities. For completing of a network diagram, you always have to see the third or fourth activities, so that the ending nodes can be finded and the diagram can be made properly. So in this case you will see that the 2 activities are merging at node 5, 2 to 5 and 3 to 5. So starting from activity 1 and starting from node 2 and node 3, we are having a merging node, that is node number 5, and 2 to 5 is one activity and 3 to 5 is another activity. Again you will see that for the last 2 activities the ending node is 6. So we have to start the 2 activities 4 to 6 and 5 to 6 in such a way that they will end at node 6. So this is node 6, this is activity 5 to 6, and this is activity 4 to 6. So this is the completion of first requirement of the question, that is drawing of the network diagram. So this is the network diagram, but we don't know the exact timing of the completion of the activity. So now we will find the duration, estimated duration of completion of each activity, and for that purpose we have to move to the table and use the formula T naught plus 4 into Tm plus Tp by 6 for each activity. Okay, so this is the formula, and we will find the values for duration, estimated duration for each activity. So starting with the first activity, you will see that for activity 1 to 2, T naught is 1, Tm is 1, yani 4 times of 1, plus Tp is 7, and 7 divided by 6. This comes out to be 4 into 1 4 plus 1 5 plus 7 12, 12 by 6, so means T. So estimated time for activity 1 to 2 is 2 weeks. Okay, similarly for activity number 2, that is 1 to 3, T naught is 1, 4 times of Tm, Tm is 4 plus Tp 7. This is divided of, so this is 4 for the 16 plus 1 17 plus 7 24, and sorry, this is 6 24 by 6, this is 4. Okay, similarly for activity 3, 2 plus 1 into 2 plus 8 by 6, 2 ones are 2 plus 2 4 plus 8, 12 by 6, that is 2, For activity 2 to 5, again for activity 2 to 5, 1 plus 1 into 4, 4 plus 8 by 1 plus 1 into 4. Okay, sorry, for third activity you will see that 2 to 8 is given and the values are 2 plus 2 into 4 plus 8 by 6, and this comes out to be 4 2s are 8, 8 plus 8 16 plus 2 18, 18 by 6, this comes out to be 3. Okay, now for activity 2 to 5, this value has been corrected as it was entered wrongly as 8, but in the exact value is 1. So for this activity 2 to 5, 1 plus 4 into 1 plus 8 by 6, and this comes, plus 1, it comes out to be 4 into 1 4 plus 5 plus 6, 6 by 6, that is 1. This value is 1. Now for activity 3 to 5, what is happening? 2 plus 5 into 4, I am writing directly the multiple, 20 plus 14 by 6, this is 36 by 6 and value is 6. Okay. Now for next activity 2 plus 20 plus 8, this is 30, 28 plus 2 30 by 6, this is 5, and for activity 5 to 6, the value is 3 plus 24 plus 15 by 6, and this comes out to be 42 by 6 and equals to 7. So these are the different estimated duration for different activities. Now we will put these values on the activities also. For activity 1 to 2, the estimated time is 2. For activity 1 to 3, estimated time is 4. For activity 1 to 4, estimated time is 3. For activity 2 to 5, the estimated time is 1. For activity 3 to 5, the time is 6. For activity 4 to 6, the time is 5, and for activity 5 to 6, estimated time is 7. Okay, now we have the duration of each activity, and now we can find the critical path, okay, for different activities or completion of a project. Now I am erasing this because I am going to write the critical paths here or the different values of. So from starting first and ending at 6, we are having 3 different paths. The paths are 1, 2, 5 and 6. We can move to 6 by 1, 3, 5 and 6, and also we can move to 6 by 1, 4, 6. These are the 3 paths. Okay, so we will write these 3 paths and then calculate the total time of the project for 3 different. So for path 1, 2, 5 and 6, the total time for the project is 2 plus 1 plus 7. 2 plus 1 plus 7, that is 10. For the second part, that is for 1, 3, 5 and 6. 1, 3, 5 and 6. The total duration is 4 plus 6 plus 7. 4 plus 6 plus 7, that is 17. And for the last part, 1, 4, 6. 1, 4, 6. The total duration for the project is 3 plus 5. 3 plus 5, that is 8. So as you know that the path which has the maximum completion time is called as the critical path. So in this case, the critical path achieved is 1, 3, 5, 6, which have the total project completion time of 17 weeks. So we have initially drawn the network diagram, also find the critical path and also find the minimum time to complete the project. Now we are writing the values, answers here. The critical path is 1, 3, 5, 6 and the total project duration, expected project duration is 17 weeks. Okay, now we have to find the variance of the project as we have to find the standard deviation. So coming back to the table, I am erasing this as it has been noted down. Okay, now what we have to find? We have to find the value of variance for all these activities. It is a simple formula. You will see that this is Tp minus T naught by 6 and whole square of the entire value. So solving for the value of different activities, we will start with the first activity. So sigma, value of sigma square for first activity is TP. TP for first activity is 7 and minus T naught minus 1 upon 6 and the square for that. That is 7 minus 1 is equal to 6 upon 6 and the square of that, and this means that square of 1 and it comes out to be 1. Okay, similarly for second activity the values are same. 7 is the TP and 1 is the T naught. So 7 minus 1 by 6 square, again the value comes out to be 1. For activity 1 to 4, the value of TP is 8 and the value of TO is 2. So it comes out to be 8 minus 6. 8 minus 2 is equal to 6 upon 6. 6 by 6 is equal to 1 and square of 1 is 1. So again it comes out to be 1. For activity 2 to 5, the values are 1 minus 1. So it's ultimately it's 0. Okay. Now for activity 3 to 5, the value of TP is 14. The value of T naught is 2, means 14 minus 2, 12 by 6 square of it, and 2 and square of 2 is equal to 4. Similarly for activity 4 to 6, the value of TP is 8, okay, and value of T naught is 2. So 8 minus 2 is equal to 6. Okay, 6 by 6 is 1 and square of 1 is 1. And for final value of final activity 5 to 6, the value of TP is 15, value of T naught is 3, it comes out to be 12. 6 by 2, 12 by 6 is 2 and square of 2 is 4. So in this way we can be able to find the values of sigma for different activities. Now what we have to find now, variance of the entire project, and this is equal to the sum of variance of all critical activities. Now as you know, the critical activities are the activities which are the activities involved in the critical path. So here you will see that there are 3 activities which are involved in the critical path. First one is the 1 to 3, second one is the 3 to 5, and third one is the 5 to 6. So we can find the total variance by adding the variance of these 3 activities. So from the table we can find the sum of variance, and that comes out to be equal to, for activity 1 to 3 it is 1, for activity 3 to 5 it is 4, and for activity 5 to 6 it's again 4, and the total variance for project is 9. As we all aware about the value of standard deviation, it is always equal to the square root of total variance. So by putting the value of total variance and the square root, we can be able to find the value of a standard deviation. So in this case the standard deviation comes out to be 3. Now this is the fourth requirement of our question, find the project standard deviation. So our standard deviation for this given question of part is equal to 3. Now the last point is, or the last question or last requirement of this question is, find the probability that project will be completed within 20 weeks. Okay, as we know that our expected time is 17 weeks and the given time is 20 weeks. So for finding the probability, what we have to find initially is the Z score. Z score is a score which can be seen in the standard normal distribution table, where we can find the value of the probability. So how we can find Z score? The formula for Z score is due date, that is 20 weeks, minus expected date, that is the project time, upon the standard deviation. As we have all these 3 values, putting these 3 values we will have 20 minus 17 by 3, that is 3 by 3 is equal to 1. So what we have received? We have received the Z score, that is equals to 1. Now using this Z score we will go to standard normal distribution table. You can find this table either in a book which can be purchased from the bookstall, or you can have these values from the internet also. So using the table we have seen that for Z score 1, probability of completion of project is 0.8413 or we can say that is probability of completion of project is 84.13%. So this is the fifth requirement of the question. Okay, so you can solve the PERT problems given for the PERT if you will be able to draw a correct network diagram. You will be aware about the formula of TE, you will be aware about the formula of sigma, you will be aware about the critical path and the variance of project. Also, what you have to find the total variance, then you have to find the standard deviation, then you have to find the Z score, and after getting the Z score, you have to correctly find the value of Z score in standard normalization table, and then you have to find the probability, and then you have to convert